Hello, in this lecture we will find out the area of quadrilateral ABCD using two different methods. In the drawing we have quadrilateral ABCD. We know that side AB of this quadrilateral equals to 4 units, side CD equals to 2 units, and we also know that side AD equals to side CB. Angle DAB, this angle equals to 30 degrees. Angle ABC, this angle equals to 90 degrees. It is a right angle. And we want to find out the area of this triangle, the area of this quadrilateral ABCD. So we will start with the first method. In the first method, we will do a construction from point D. We will draw perpendicular to AB. So this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. And we will define the touching point from the perpendicular. We will define the touching point of the perpendicular from point D to AB as point E, and we will focus on the right triangle, triangle AED. On the right triangle, triangle AED, and we also will define line segment DE as A, that is to say line segment DE equals to A units in its length. So in triangle ADE, sinus 30 degrees equals to DE over AD. I repeat again, in triangle ADE, sinus 30 degrees equals to DE over AD, but we know that DE equals to A, so we'll substitute DE by A over AD. So sinus 30 degrees equals to A over AD. Sinus 30 degrees is 1 over 2. So 1 over 2 equals to A over AD. Here we will cross multiply this equation and we will get that AD equals to 2A So we found out that AD equals to 2A. It is given us in the question that AD equals to CB. We know that AD equals to CB, and we found out that AD equals to 2A. AD equals to 2A. So from this equation, we will derive that CB also equals to 2A. CB equals to 2A. So we can write here that CB equals to 2A. In the next step, From point D, we will draw perpendicular to CB. We will define the touching point between the perpendicular from point D to CB as point F. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So we will I will present to you a new rule, rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. I will read rule number 1 again. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. We will focus on quadrilateral DEBF. So in quadrilateral DEBF, we have 3 right angles, 1, 2, 3. The sum of 3 right angles is 90 times 3, 90 degrees times 3 is 270 degrees, plus we define this angle as angle x, so plus the 4th angle that equals to x degrees in its size. This must be equal to 360 degrees according to rule number 1. Here we will subtract 270 degrees from this equation, and we will get that angle x equals to 360 degrees minus 270 degrees, that is to say angle x equals to 90 degrees. So we found out that angle x equals to 90 degrees. So we will change this angle, angle x, to a right angle. So actually, as you can see from the drawing, quadrilateral EBDF has 4 right angles, and we also have rule number 2. According to rule number 2, any quadrilateral that has four right angles must be at least a rectangle. So I will read rule number 2 again. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle. And because of the fact that quadrilateral DFEB has 4 right angles, we will relate to quadrilateral DFEB as a rectangle. So quadrilateral DFEB is a rectangle according to rule number 2. And we also have rule number 3. According to rule number 3, the opposite sides of a rectangle are equal to each other. We'll read rule number 3 again. According to rule number 3, the opposite sides of a rectangle are equal to each other. Therefore, in rectangle DFEB, we can derive that DE equals to FB. According to rule number 3, DE equals to FB. According to rule number 3, but we already know that DE equals to A. According to our definition, DE equals to A units. From this equation, we will derive that FB also equals to A. So actually here, FB equals to A units. And what is the value of CF? The value of CF, you can see from the drawing easily that CF equals to CB minus FB. I'll repeat again. From the drawing you can see easily that CF equals to CB minus FB. That is to say, CF equals to CB equals to 2A and FB equals to A, so CF equals to 2A minus A, that is to say 2A minus A is A, so we found out that CF equals to A. CF equals to A. In the next step, we will join together points D and B by a straight line. And we will prove that triangle DCF congruent to triangle DFB. I'll repeat again. We will prove the triangle DCF congruent to triangle DFB. It is actually, yes, triangle DCF congruent to triangle DFB. So why those two triangles congruent to each other? First of all, you know that CF equals to FB equals to A. CF equals to FB equals to A. I'll repeat again. CF equals to FB equals to A. We also know that those two angles, they are equal to each other, they are both equal to 90 degrees. That is to say, angle CFD, this angle, is equal to this angle, BFD, and both angles are equal to 90 degrees. I'll repeat again. Angle CFD equals to angle BFD, and they are both equal to 90 degrees. And we also have a common side. DF is a common side. It belongs to both triangles, so we can write down that DF equals to itself. DF equals to DF is a common side that belongs to both triangles. So DF equals to DF is a common side that belongs to both triangles. So we actually proved that triangle DCF, this triangle, DCF, congruent, this is the sign of congruent, to triangle DFB, according to side angle side rule. I'll repeat again. We actually proved that triangle DCF congruent to triangle DFB according to side angle side rule. So what is side angle side rule? Side angle side rule is that if you prove that two sides in one triangle and the angle that is located between those two sides, and the angle that is located between those two sides in one triangle congruent to two sides and the angle between those two sides in another triangle, then you proved that those two triangles congruent to each other according to side angle side rule. And we actually proved that those two sides and the angle between those two sides, that is to say this angle that is a right angle in triangle DCF, congruent to those two sides and the angle that is located between those two sides, that is to say this right angle in triangle DFB. Therefore we proved that those two triangles can point to each other according to side angle side rule. And from the fact that those two triangles can point to each other, we will conclude that DC equals to DB. TC equals to DB. And actually, DC equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can point to each other, therefore the corresponding sides, that is to say CD and DB, will be also equal to each other. But we know it is given us in the question that DC equals to 2 units. DC equals to 2 units. From this equation, we will derive that DB also equals to 2 units. DB also equals to 2 units. So here we can write down that DB equals to 2 units. In the next step, I will present to you a new rule that is actually the law of cosines. So what is the law of cosines? The law of cosines, first of all, it is true in any triangle. So we can write down that in any triangle, we can use the law of cosines in any triangle. So actually, if we have triangle ABC, that could be any triangle. This is triangle ABC, and we know that the length of side AB is A units, the length of side BC is B units, and the length of side AC is C units, and the angle between AB and BC is theta. Then, according to the law of cosines, A square plus B square minus 2 times A times B times cosine theta equals to C square. A square plus B square minus 2 times A times B times cosine theta equals to C square. Here we will subtract C square and add 2AB cosine theta to this equation, and we will get that A square plus B square minus 2 times A times B times cosine theta. It is actually A square plus B square minus C square equals to 2 times A times B cosine theta. Again, we get that A square plus B square minus C square equals to 2 times A times B times cosine theta. We will divide this equation by 2 times AB, and we will get that cosine theta equals to A square plus B square minus C square over 2 times AB. So in any triangle, cosine theta equals to A square plus B square minus C square over 2 times AB. We can actually implement the law of cosines in our drawing. we will implement the law of cosines, in triangle ADB. So I will copy triangle ADB in a new page, and we will implement the law of cosines in this triangle. So triangle ADB is actually this triangle. So this is actually triangle ADB. AD equals to 2A, AB equals to 4 units, and DB equals to 2 units. According to the law of cosine, cosine 30 degrees will be equal to 2A squared plus 4 squared minus 2 squared over 2 times 2A times 4. I'll repeat again. We implemented the law of cosine, in triangle ADB, and we got that cosine 30 degrees equals to 2A squared plus 4 squared minus 2 squared over 2 times A times 4. We know that cosine 30 degrees is square root of 3 over 2. Square root of 3 over 2 equals to 2A squared. 2A squared is 4A squared plus 4 squared is 16, and minus 2 squared is minus 4. 16 minus 4 is 12 over 2 times 4 is 8, and 8 times 2A is 16A. We will multiply this equation by 16A, and we will get that square root of 3 over 2 times 16A equals to 4A squared plus 12. 16 over 2 is 8, so we will get that 8 times square root of 3 times A equals to 4A squared plus 12. Here we will divide this equation by 4, and we will get that 8 over 4 is 2, so it is 2 times square root of 3 times A equals to 4 over 4 is A, 4 over 4 is 1, so here we will get A squared plus 12 over 4 is 3. We subtract 2 times square root of 3 times A from this equation, and we will get that A squared plus 3 minus 2 times square root of 3 times A equals to 0. We know that 3 is square root of 3 squared, so we will substitute 3 by square root of 3 squared, and we will get that A squared plus square root of 3 squared minus 2 times A times square root of 3 equals to 0. Actually, this expression is very similar to the algebraic identity that states that A squared plus B squared minus 2 times AB equals to A minus B squared. that equals to 0. In our specific expression, a equals to a, b equals to the square root of 3. So a, this expression equals to a minus b squared, and a is a and b is square root of 3, so a minus b squared is a minus square root of 3 squared, that equals to 0. Here we'll take a root out of this equation and we'll get that a minus square root of 3 equals to 0. Here we know that the square root of 0 is 0, so here we'll get 0. We will add square root of 3 to this equation and we will get that a equals to square root of 3 units. So we found out that a equals to square root of 3 units. So we can write here that a equals to square root of 3 units. Here also a equals to square root of 3 units, and here also a equals to square root of 3 units. In the next step, we will focus on triangle DEB. We will implement the Pythagoras theorem on triangle DEB. So in triangle DEB, according to the Pythagoras theorem, DE squared plus EB squared equals to DB squared I'll repeat again. In triangle DEB, according to the Pythagoras theorem, PT is the abbreviation for Pythagoras theorem. We will get the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, DE square equals to EB square. DE square plus EB square equals to DB square. DE square is square root of 3 square. Square root of 3 square is 3. Plus EB square. EB square is EB square. EB square, EB is the missing variable, so we will leave it as it is. Equals to DB square. DB equals to 2. So DB square is 2 square. 2 square is 4. So in conclusion, we found out that three plus EB square equals to 4. We will subtract 3 from this equation and we will get that EB square equals to 3 minus 4. 3 minus 4 is 1. We'll take a root out of this equation and we will get that EB equals to the square root of 1. The square root of 1 is 1. So we found out that EB equals to 1. We can write here that EB equals to 1. But because of the fact that the opposite sides of a rectangle are equal to each other, EB equals to DF. But EB equals to 1, so DF will be also equal to 1. What is the value of AE? You can see easily from the drawing that AE equals to AB minus BE. AB minus BE equals to AE. I repeat again, AE equals to AB minus BE. You can see it easily from the drawing. So AE equals to AB, that is 4 units, minus BE, that is 1 unit. 4 minus 1 is 3, so AE equals to 3. Again, AE equals to 4 minus 1, that is to say A equals to 3 units. So now we can find easily the area of quadrilateral ABCD. Why? Because the area of quadrilateral ABCD will be equal to the area of triangle ADE, the right triangle ADE, plus the area of rectangle DFEB, plus the area of the right triangle CFD. So I write it down. The area of quadrilateral ABCD will be equal to the area of triangle ADC, that is the right triangle, plus the area of quadrilateral DFEB, plus the area of triangle CFD, this right triangle. So I repeat again, the area of quadrilateral ABCD, the squared brackets are the sign for the area, so this means the area of triangle quadrilateral ABCD is equal to the area of triangle ADC plus the area of quadrilateral DFEB plus the area of triangle CFD. So the area of quadrilateral ABCD will be equal to the area of triangle ADC, the area of triangle, it is actually triangle ADE, this triangle is triangle ADE, so it is the area of triangle ADE. The area of triangle ADE equals to AE, that is the base, times AED, that is the height, over 2. So it is AE, that is the base of the triangle, times the height of the triangle, that is DE, over 2. I'll repeat again. The area of the right triangle AD equals to AE times DE over 2. The area of quadrilateral DFEB will be equal to the width of the triangle, that is actually EB, times the length of the triangle, that is actually BF. So the area of quadrilateral DFEB equals to the width of the triangle, that is EB, times the length of the triangle, that is BF. And the area of the right triangle CFD will be equal to the base of the triangle, that is actually DF, times the height to the base, that is actually CF, over 2. I repeat again, the area of the right triangle DCFD equals to the base of the triangle, that is DF, times the height to the base, that is CF, over 2. So here AE equals to 3 units, DE equals to square root of 3 units over 2. So we found out that the area of the right triangle AD equals to square root of 3 times 3 over 2 square units plus the area of triangle DFEB, that is actually EB is 1 times BF, that is square root of 3. That is to say, the area of rectangle DFEB equals to square root of 3 square units, and the area of the right triangle CFD equals to the base of the triangle, that is actually DF, and DF equals to 1 times CF equals to square root of 3 units over 2. So we found out that the area of quadrilateral ABCD equals to the sum of these 3 expressions. Here we will multiply square root of 3 by 2, and then we will divide it by 2 in order to have a common factor with those 2 expressions. So we will multiply it by 2, and then we will divide it by 2. Then we will take a common factor of square root of 3 out of these expressions, and we will get that we took a common factor square root of 3 from this expression. So inside the brackets we will have here 3. Here we took a common factor of square root of 3, so inside the brackets what is left is 2. And here also we took a common factor of square root of 3, so inside the brackets we left only with 1. And in the denominator we have 2. So square root of 3, 1 plus 2 is 3, 3 plus 3 is 6, 6 over 2 is 3 times square root of 3. That is the area of quadrilateral ABCD is equal to 3 times square root of 3 square units, or in terms of numbers it equals to 5.196 square units. I'll repeat again, the area of quadrilateral ABCD is equal to either 3 times square root of 3 square units, or in terms of numbers it equals to 5.196 square units. We finish with the first method. In the next step I will present to you how to find out the area of quadrilateral ABCD using the second method. In the second method we will do another construction. From point C we will draw perpendicular to BC. So actually this angle will be a right angle, that is to say it will be equal to 90 degrees. And from point A we will draw perpendicular to AB, that is to say this angle will be a right angle, that is to say it will be equal to 90 degrees. So this is a right angle. We will define the intersection point between the perpendicular from point A and the perpendicular from point C as point E. Again, the intersection point between the perpendicular from A and the perpendicular from C will be defined as point E, and we will define this angle is angle X. So we actually created here quadrilateral ABCE. Okay, this is quadrilateral ABCE. And we know that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, especially in quadrilateral ABCE, the sum of its angles must be equal to 360 degrees according to rule number 1. That is to say, quadrilateral ABCE has 3 right angles, 1, 2, 3. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle, that is angle X, must be equal to 360 degrees according to rule number 1. I repeat again. The sum of the angles in quadrilateral ABCE must be equal to 360 degrees according to rule number 1. That is to say, 270 degrees plus the size of angle X must be equal to 360 degrees. Here we will subtract 270 degrees from this equation, and we will get that angle X equals to 360 degrees minus 270 degrees. That is to say, angle X equals to 90 degrees. So we found out that angle X is a right angle. That is to say, it equals to 90 degrees. So we will substitute angle X by a right angle. So this angle is a right angle. That is to say, it equals to 90 degrees. So actually, as you can see from the drawing, quadrilateral ABCE has 4 right angles, and any quadrilateral that has 4 right angles must be at least a rectangle, so we will relate to quadrilateral ABCE as a rectangle. According to rule number 2, quadrilateral ABCE is a rectangle. According to rule number 2. And we also have rule number 3 that states that the opposite sides of a rectangle are equal to each other. So the opposite sides of rectangle ABCE are equal to each other. That is to say, AB equals to CE. AB equals to CE according to rule number 3, that the opposite sides of a rectangle are equal to each other. But we know it is given us in the question that AB equals to 4 units. From this equation, we will derive that CE also equals to 4 units. CE equals to 4 units. So we can write here that CE equals to 4 units. Likewise, CB equals to AE. According to rule number 3, CB equals to AE. And if we define CB as X, then AE also equals to X. So CB equals to X according to our definition, and therefore AE will be also equal to X. According to rule number 3, of course. And it is given us in the question that DC equals to AD. Actually, it's given us in the question that AB equals to CD. AB, no, it is actually what is given us in the question is that AD equals to CB. AD equals to CB. AD equals to CB. That is what is given us in the question. Again, AD equals to CB. But AB equals to X. Therefore, AD will be also equal to X. Okay. And we will join points D and B by a straight line. And we'll join points D and E by a straight line. We will focus on triangle AED. First of all, we know that angle EAB is a right angle and angle DAB equals to 30 degrees. So 90 degrees minus 30 degrees will be equal to the value, it is the value of this angle. 90 degrees minus 30 degrees it is the value of this angle, that is to say angle EAD will be equal to 60 degrees. This angle is 60 degrees. So I will draw triangle AED in a new page and we will analyze triangle AED. Okay. We'll analyze triangle AED. So actually this is triangle AED. I copied it from this original drawing. We know that in triangle AED, AE equals to ED equals to X, and we have the rule that in front of equal sides in the triangle there are equal angles. In front of these two sides that are equal to each other, there are equal angles. That is to say, those two angles that are located in front of equal sides must be equal to each other. That is to say, those two sides, those two angles will be equal to each other. And if we define one angle as y, then the other angle must be also equal to y. And according to the rule that the sum of the angles in any triangle is equal to 180 degrees, we will get that the sum of the angles in triangle AED is actually y plus y plus 60 degrees. In total, the sum of those three angles must be equal to 180 degrees. Y plus y is 2y plus 60 degrees equals to 180 degrees. Here we will subtract 60 degrees from this equation and we will get that 180 degrees minus 60 degrees is 120 degrees. Here we will divide this equation by 2, and we will get that angle y equals to 180 degrees over 2 is 60 degrees. So we found out that angle y equals to 60 degrees. This angle y equals to 60 degrees, and this angle y also equals to 60 degrees. Therefore, actually, triangle AED, this triangle is an equilateral triangle. Equilateral triangle that is to say, all of its sides are equal to each other, so ED will be also equal to x, and all of its angles are equal to 60 degrees. So actually, in the original drawing, you can also write down that ED equals to x, this angle equals to 60 degrees, and this angle will be also equal to 60 degrees. So what is the value of this angle? Angle DEC, the angle DEC equals to 90 degrees minus the size of this angle. 90 degrees minus the size of this angle is 30 degrees, so we actually found out that angle CED equals to 30 degrees. Angle CED equals to 30 degrees. In the next step, we will prove that triangle ADB congruent to triangle CDE. I write it down. Triangle ADB congruent to triangle, this triangle ADB congruent to triangle EDC. Okay. Why those two triangles congruent to each other? First of all, we know that AB equals to EC equals to 4 units. AB equals to EC equals to 4 units. I will repeat again. AB equals to EC equals to 4 units. We also know that those two angles, they are equal to each other, they are both equal to 30 degrees. So here, angle BAD, this angle, equals to this angle that is actually angle CED, and they are both equal to 30 degrees. I will repeat again, angle BAD equals to angle CED equals to 30 degrees. And AD equals to ED equals to x. AD equals to ED equals to x. I'll repeat again. AD equals to ED equals to x. So we actually proved that triangle ADB congruent to triangle EDC according to angle side angle rule. I repeat again, we proved the triangle ADB can go into triangle EDC according to angle side angle rule, and from the fact that those two triangles can go into each other, we will conclude that DC equals to DB. DC equals to DB, and DC equals to DB according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides DC and DB will be equal to each other. But it is given us in the question that DC equals to 2 units. DC equals to 2 units. And from this equation, we will derive that DB also equals to 2 units. DB equals to 2 units. DB equals to 2 units. So here, DB equals to 2 units. In the next step, we will implement the law of cosines on triangle ADB. So I will copy triangle ADB in a new page, and we will implement the law of cosines on this triangle, triangle ADB. So triangle ADB, so this is triangle ADB. We will implement the law of cosines on triangle ADB. According to the law of cosines on triangle ADB, we will get that cosine 30 degrees equals to x squared plus 4 squared minus 2 squared over 2 times x times 4, that equals to actually x squared plus 4 squared is 16, minus 2 squared is minus 4, 16 minus 4 is 12, over 2 times 4 is 8, 8 times x is 8x. So we know that cosine 30 degrees equals to square root of 3 over 2, and it equals to x squared plus 12 over 8x. Here we will multiply this equation by 8x, and we will get that square root of 3 over 2 times 8x equals to x squared plus 12. 8 over 2 is 4, so it is 4 times square root of 3x equals to x squared plus 12. We will subtract 4 times of square root of 3 times x from this equation, and we will get that x squared plus 12 plus minus 4 times square root of 3x equals to 0. Here we will substitute 12 by 2 times square root of 3 squared, so x squared equals to 2 times square root of 3 squared. 2 times square root of 3 squared is 12, so we can substitute 12 by 2 times square root of 3 squared, and we will substitute 4 by 2 times 2, and we will get that 2 times x times 2 times square root of 3 equals to 0. So this expression is very similar to the expression a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression, a equals to x and b equals to 2 times square root of 3 units. So a minus b squared, so we can substitute this expression by a minus b squared according to this algebraic identity. So a minus b squared will be equal to a is x and b is 2 times square root of 3, so it is x minus 2 times square root of 3 squared equals to 0. Here we will take a root out of this expression and we will get that x minus 2 times square root of 3 equals to 0 because of the fact that the square root of 0 is 0. So we got that x minus 2 times square root of 3 equals to 0. We will add 2 times square root of 3 to this equation and we will get that x equals to 2 times square root of 3 units. So we found out that the value of x is 2 times square root of 3 units. So we can write here that x equals to 2 times square root of 3 units, and also here x equals to 2 times square root of 3 units, and here also x equals to 2 times square root of 3 units, and here also here x equals to 2 times square root of 3 units. And the area of quadrilateral ABCD, the area of quadrilateral ABCD, quadrilateral ABCD consists of two triangles, triangle CDE and triangle ADE. So the sum of the areas of those two triangles will be equal to the area of quadrilateral ABCD. So the area of quadrilateral ABCD equals to the area of triangle CDE plus the area of triangle EDA. I'll repeat again, the area of quadrilateral ABCD will be equal to the area of triangle CDE plus the area of triangle EDA. In order to find out the area of triangle CDE, this triangle, we will draw perpendicular from point D to CE. So this angle is a right angle, it equals to 90 degrees, and this angle it is also a right angle. We will define the touching point between the perpendicular from point D to CE as point S. We will define line segment DS as edge, that is actually the height to the base CE. So the area of triangle DCE will be equal to the base of the triangle, that is actually EC, times the height to the base, that is actually edge, over 2. In the next step, we will calculate the value of the height of triangle DCE. The height of triangle DCE it is actually sinus 30 degrees. equals to h over dE, and dE is 2 times square root of 3 units. So in triangle ESD, I will repeat again, in triangle ESD we know that sinus 30 degrees equals to h over 2 times square root of 3 units. We also know that sinus 30 degrees is equal to 1 over 2, so 1 over 2 equals to h over 2 times square root of 3. Here we will multiply this equation by 2 times square root of 3, and we will get that h equals to 2 times square root of 3 over 2. 2 over 2 is 1, so we found out that the value of h, the height, equals to square root of 3 units. So the height of triangle CDE is square root of 3 units. So the area of triangle CDE, it is actually CE. The base, that is CE. CE equals to 4 units. H, we found that H equals to square root of 3 over 2. So we found out that the area of triangle CDE equals 4 over 2 is 2. So we found out that the area of triangle CDE equals to 2 times square root of 3 square units. And the only thing that is left to find is to find out the area of triangle DEA. What is the area of triangle DEA? The area of triangle DEA we will calculate the area of triangle DEA according to a special formula. First of all, we will find out the semi-perimeter of triangle ADE. What is the semi-perimeter of any triangle? The semi-perimeter of any triangle is the perimeter over 2. And the perimeter we are going to find out the area of quadrilateral ABCD. Therefore, the area of quadrilateral ABCD is equal to the area of triangle ABD. That is actually the area. Actually, we found out the area of triangle CDE. But because of the fact that the area of triangle CDE must be equal to the area of triangle ADE, because of the fact that those two triangles can go into each other, therefore they have also the same areas. So the area that we found, that is the area of triangle EDC, will be equal to the area of triangle ADB. So the area of triangle ADB, according to what we have already found out, it is actually 2 times square root of 3 units. I'll repeat again, because of the fact that triangle ADB can go into triangle CDE, we have already proved it, they have also the same areas. So the area that we found is equal to the area that we want to find, that is the area to find, that is the area of triangle ADB, that is to say the area of triangle ADB equals to 2 times square root of 3 units. In the next step we will find out the area of triangle BDC, the area of triangle BDC, the area of triangle BDC find it according to a special formula. We will calculate the semi-perimeter of triangle BDC. The semi-perimeter of triangle BDC is the sum of its sides over 2. The sum of its sides is 2 plus 2 plus 2 times square root of 3 units. So the perimeter of triangle BDC over 2 is equal to the semi-perimeter. So S, that is the abbreviation for the semi-perimeter, will be equal to 2 plus 2 plus 2 times square root of 3 over 2. 2 plus 2 is 4. 4 plus 2 times square root of 3 over 2 equals to 4 over 2 is 2. And 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle BDC equals to 2 plus square root of 3 units, and the area of triangle BDC will be equal, the area of triangle BDC will be equal to the square root of S times S minus A times S minus B times S minus C. S is the semi-perimeter that we already found out that is actually S equals to 2 plus square root of 3 units. We know that A equals to 2 units, B equals to 2 units, and C equals to 2 times square root of 3 units. So we will put the data inside this equation and we will find out the area of triangle BDC. We will get that the area of triangle BDC equals to S is 2 times 2 plus square root of 3 units, all inside the root. S minus A is 2 plus square root of 3 units minus 2 is square root of 3 units. S minus B, it is the same result because A equals to B, so it also will be equal to square root of 3 units. And S minus 3 is 2 plus square root of 3 minus 2 times square root of 3, that is actually 2 minus square root of 3. So here square root of 3 times square root of 3 is 3, and 2 plus square root of 3 times 2 minus square root of 3, we will find out the value of this multiplication according to the algebraic identity that A plus B times A minus B equals to A squared minus B squared. Here A equals to 2, so A squared is 2 squared, 2 squared is 4, minus B squared, B equals to square root of 3 units, and square root of 3 units squared is 3. So the area of triangle BDC equals to square root of 3 times 4 minus 3 is 1. 3 times 1 is 3, so we found out that the area of triangle BDC equals to square root of 3 units. Therefore, the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle DBC I repeat again, the area of quadrilateral ABCD equals to the area of triangle ADB, that is actually 2 times square root of 3 units, plus the area of triangle DBC, that is actually 1 times square root of 3 units. So 2 times square root of 3 units plus 1 times square root of 3 units is 3 times square root of 3 units. So we found out that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. So in the next step, we will summarize the lecture. Actually, we found out the area of quadrilateral ABCD in 2 different methods. In the first method, we made a construction from point D. We drew perpendicular to AB. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We define the touching point from the perpendicular from point D, and AB is point E. Then we focused on triangle ADB, that is a right triangle. On triangle ADE, sinus 30 degrees equals to DE over AD. We define DE as A. Again, in triangle ADE, sinus 30 degrees equals to DE over AD. We define DE as A, so DE is A. We can substitute DE by A over AD. Sinus 30 degrees equals to A over AD. Sinus 30 degrees is 1 over 2, so we got that 1 over 2 equals to A over AD. We just multiplied this equation, and we got that AD equals to 2A. Here we found out that AD equals to 2A. And but we know it is given us the question that AD equals to CB. AD equals to CB according to what is given us in the question, and we found out that AD equals to 2A. From this equation, we will derive that CB also equals to 2A. CB equals to 2A. Then I presented to you rule number 1. According to rule number 1, the sum of the angles in any quadrilateral is equal to 360 degrees. So, first of all, we actually drew perpendicular from point D to CB. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees. So if we focus on quadrilateral DFEB, we will get that quadrilateral DFEB has 3 right angles, 1, 2, 3. The sum of 3 right angles is equal to 90 degrees times 3 is 270 degrees, plus the size of this angle that we define as angle X. So the sum of all angles in quadrilateral DEBF must be equal to 360 degrees according to rule number 1. That is to say 270 degrees plus x equals to 360 degrees. We subtracted 270 degrees from this equation, and we got that angle x equals to 90 degrees. So we found out that all the angles inside quadrilateral DEFB are right angles. They are all equal to 90 degrees. And we have rule number 2. According to rule number 2, any quadrilateral that has 4 right angles must be at least a rectangle. Quadrilateral DFEB has 4 right angles. Therefore, we will relate to quadrilateral DFEB as a rectangle. This is true according to rule number 2. We also have rule number 3 that states that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle DFEB are equal to each other. What does it mean? It means that DE equals to FB. DE equals to FB according to rule number 3. But we define DE as A, that is to say D equals to A. From this equation, we will derive that FB also equals to A. FB equals to A. So what is the value of FC? FC equals to CB minus FB. Here, CF equals to CB minus FB. So CF equals to CB is 2A. FB is A, so CF equals to 2A minus A. That is to say, CF equals to A. 2A minus A is A, so CF equals to A. And we proved that those two triangles can go into each other. Why those two triangles can go into each other? First of all, we proved that triangle DCF can go into triangle DFB. Why those two triangles can go into each other? First of all, CF equals to BF equals to A, CF equals to FB equals to A, CFD equals to BFD equals to 90 degrees. Those two angles, they are equal to each other, they are both equal to 90 degrees. And we also have a common side, DF equals to DF as a common side. It belongs to both triangles. Therefore, we proved that triangle DCF can go into triangle DFB according to side angle side rule. Okay? And we can derive from the fact that those two triangles can go into each other that DC equals to DB, DC equals to DB, according to the rule that corresponding sides and congruent triangles are equal to each other. But we know that DC equals to 2 units. It is given us in the question. From this equation, we will derive that DB also equals to 2 units, DB equals to 2 units. Then I presented to you the law of cosines. What is the law of cosines? The law of cosines is true in any triangle. If we have triangle ABC, that could be any triangle. We know that the length of AB is A units, the length of AC is C units, and the length of BC is B units, and the angle between AB and BC is equal to theta. Then, according to the law of cosines, A squared plus B squared minus 2 times AB cosine theta equals to C squared. We subtracted C squared and added 2 times AB cosine theta to this equation, and we got that A squared plus B squared minus C squared equals to 2 times AB cosine theta. We divided this equation by 2 times AB, and we got that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. So in any triangle, this equation is true. We implemented the law of cosines in our triangle. In triangle DAB, so I copied triangle DAB to this page, and according to the law of cosine on triangle DAB, cosine 30 degrees equals to 2A squared plus 4 squared minus 2 squared over 2 times 2A times 4. Cosine 30 degrees equals to square root of 3 over 2. 2A squared is 4A squared. 4 squared is 16. Minus 2 squared is minus 4. So 16 minus 4 is 12. So in the numerator we have, in conclusion, 4A squared plus 12. And in the denominator of this expression we have 2 times 4 is 8. 8 times 2a is 16a. In the denominator we have 16a. So here we will multiply this equation by 16a, and we got that square root of 3 over 2 times 16a equals to a squared plus 4a squared plus 12. 16 over 2 is 8, so in conclusion we got that 4 times square root of 3 times a equals to 4a squared plus 12. Here we divided this equation by 4, and we got that 8 over 4 is 2. So we got here 2 times square root of 3 times a equals to 4 over 4 is 1. So here we will have a squared, and 12 over 4 is 3. So in conclusion we got that 2 times square root of 3 times a equals to a squared plus 3. We subtracted 2 times square root of 3a from this equation, and we got that a squared plus 3 minus 2 times square root of 3 times a equals to 0. We substituted 3 by square root of 3 squared, and we got that a squared plus square root of 3 squared minus 2 times a times square root of 3 equals to 0. And here this expression is very similar to the algebraic identity that a squared plus b squared minus 2ab equals to a minus b squared, that equals to 0. In our specific expression, a equals to a and b equals to square root of 3 units. So a minus b, so we can substitute this expression, our specific expression, by a minus b squared, because according to this algebraic identity, those two expressions, they are equal to each other. So a minus b squared, a is a and b is square root of 3, so a minus b squared is actually a minus square root of 3. Square equals to 0. We took a root out of this equation, and we got that a minus 3 square equals to 0, because the square root of 0 is 0. We added square root of 3 to this equation, and we got that a equals to square root of 3 units. So we found out that a equals to square root of 3 units. That is to say, here a equals to square root of 3 units, here also a equals to square root of 3 units, and here also a equals to square root of 3 units. Then in triangle DEB, according to the Pythagoras theorem, this right triangle, triangle DEB, we will get that DE squared plus EB squared equals to DB squared. DE squared plus EB squared equals to DB squared. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. DE equals to square root of 3. Therefore, DE squared is square root of 3 squared. Square root of 3 squared is 3. Square root of 3 squared is 3. EB squared is EB squared. And DB equals to 2. So DB squared is 2 squared. 2 squared is 4. So we got that 3 plus EB squared equals to 4. We subtracted 3 from this equation, and we got that EB squared equals to 4 minus 3. 4 minus 3 is 1, so we got that EB squared equals to 1. We took a root out of this equation, and we got that EB equals to square root of 1. Square root of 1 is 1. So we found out that EB equals to 1. But because of the fact that the opposite sides of a rectangle are equal to each other, DF will be also equal to 1. What is the value of AE? From the drawing you can easily see that AB minus BE equals to AE. AE equals to AB minus BE, so AE equals to AB, that is 4, minus AB, that is 1. AE equals to 4 minus 1. 4 minus 1 is 3. So we found out that AE equals to 3 units. Now we can easily find out the area of quadrilateral ABCD. The area of quadrilateral ABCD equals to the area of triangle ADE plus the area of rectangle DFE FEB plus the area of triangle DCFD. Okay? So the area of the right triangle, triangle ADE, equals to AE, that is the base, times the I to the base, that is ED over 2. AE times DE over 2. AE is 3, DE is square root of 3, so the area of triangle AD is square root of 3 times 3 over 2. The area of rectangle DFEB equals to the length of the rectangle times the width. The length of the rectangle is EB equals to 1, and the width of the rectangle is square root of 3. Actually, the length of the rectangle is square root of 3, and the width of the rectangle is EB, that is 1. So EB times BF equals to actually 1 times square root of 3. So the area of quadrilateral DFEB equals to square root of 3 square units. And the area of the right triangle, triangle CFD, equals to the base of the triangle, that is DF, times the I to the base, that is FC over 2. So it is actually DF times CF over 2. DF is 1, and FC is square root of 3 units over 2. So the area of the right triangle CFD equals to square root of 3 over 2. Here we multiplied the square root of 2 by 2, and then we divide it by 2 in order to have a common factor with those two expressions. Then we took a common factor of square root of 3 from these three expressions. So square root of 3 is a common factor. So inside the brackets, from this expression we will get that inside the brackets we will have 3. From this expression inside the brackets we will have 2. From this expression inside the brackets we will have 1, all divided by 2. 3 plus 2 is 5, 5 plus 1 is 6. So the area of quadrilateral ABCD equals to square root of 3 times 6 over 2 is 3. So the area of quadrilateral ABCD will be equal to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. We finished with the first method. Then I presented to you how to find out the area of quadrilateral ABCD using the second method. In the second method, we did another construction. Actually, from point C, we drew perpendicular to CB, and from point A, we drew perpendicular to AB. So this angle is equal to 90 degrees, and this angle also equals to 90 degrees. We define the intersection point between the perpendicular from A and the perpendicular from C at point E. So we created quadrilateral ABCE that is actually has 3 right angles, 1, 2, 3, and the sum of 3 right angles is 90 times 3, that is to say it equals to 270 degrees, plus the size of the 4th angle that we defined as x. The sum of those 4 angles must be equal to 360 degrees according to rule number 1. We subtracted 270 degrees from this equation, and we got that angle x equals to 360 degrees minus 270 degrees, it equals to 90 degrees. So, as you can see from the drawing, all the angles inside quadrilateral ABCE are right angles. Therefore, according to rule number 2, quadrilateral ABCE is a rectangle. Okay? And according to rule number 3, the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle ABCE are equal to each other. It means that that AB equals to EC, AB equals to EC, according to rule number 3. But we know that AB equals to 4 units. It is given as the equation. From this equation, we will derive that CE also equals to 4 units. CE equals to 4 units. Likewise, BC equals to AE according to rule number 3. BC equals to AE according to the rule that the opposite sides of a rectangle are equal to each other. And we define CB as X. So from this equation, we derive that AE also equals to X. So here AE equals to X and CB also equals to X. Then in the next step, we join points E and D together by a straight line, and we join points D and B by a straight line. Here it is given us in the question that angle DAB equals to 30 degrees. This angle is equal to angle EAB equals to 90 degrees according to our construction. So the value of this angle, angle EAD, will be equal to 90 degrees minus 30 degrees. That is to say, this angle equals to 60 degrees. And we also know that AD equals to CB according to what is given us in the question. But BC equals to X, therefore AD will be also equal to X. Again, I repeat, AD equals to, so BC also equals to, so AD also equals to X. And so here, in triangle AED, we have one angle that equals to 60 degrees, and it has two sides that are equal to each other. So I drew triangle AD in a new page, and we analyzed triangle AD. This is triangle AD. You know that those two angles are equal to each other, and this angle equals to 60 degrees. So we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of equal sides must be equal to each other. So if this angle is y, this angle must be also equal to y. And we know that the sum of the angles in any triangle is equal to 180 degrees. That is to say, angle y plus this angle that equals to 60 degrees must be equal to 180 degrees because of the fact that the sum of the angles in triangle AED must be equal to 180 degrees. Okay? Y plus y is 2y, so 2y plus 60 degrees equals to 180 degrees. We subtracted 60 degrees from this equation, and we got that 2y equals to 180 degrees minus 60 degrees is 120 degrees. We divided this equation by 2, and we got that angle y equals to 180 degrees over 2, that is to say angle y equals to 60 degrees. So angle y equals to 60 degrees. This angle equals to 60 degrees, and this angle that is angle y also equals to 60 degrees. So we found out that triangle AED is an equilateral triangle. That is to say, ED also equals to X. All of its angles are equal to 60 degrees, of course. So here we can write down that this angle equals to 60 degrees, this angle also equals to 60 degrees, and DE equals to X. So we found out that angle AEC is a right angle. It equals to 90 degrees. So 90 degrees minus this angle that actually 90 degrees minus this angle that we found out that it equals to 60 degrees will be equal to this angle. So this angle DEC will be equal to 90 degrees minus 60 degrees, that is to say this angle equals to 30 degrees. Angle DEC equals to 30 degrees. Then we proved that those two triangles can go into each other. Triangle CDE can go into triangle ADB. So triangle ADB can go into triangle ADC. Why those two triangles can go into each other? First of all, we know that AB equals to EC equals to 4 units. AB equals to EC equals to 4 units. Those two angles, they are equal to each other, they are both equal to 30 degrees. So angle BAD equals to angle CD equals to 30 degrees. And AD equals to DE equals to X. AD equals to ED equals to X. So we proved that triangle ADB can go into triangle EDC according to angle side angle rule. And from the fact that those two triangles can go into each other, we will conclude that DC equals to BD. DC equals to BD. DC equals to BD, but it is given us in the question that DC equals to 2 units. From this equation, we will conclude that DB also equals to 2 units. DB equals to 2 units. Then we implemented the law of cosines on this triangle ADB. So I copied this triangle in a new page, and we implemented the law of cosines on this triangle ADB. Okay, so this is actually triangle ADB. We implemented the law of cosines on this triangle. According to the law of cosines, cosine 30 degrees equals to x squared plus 4 squared minus 2 times minus 2 squared over 2 times x times 4. X squared, 4 squared is 16, minus 2 squared is 4, so 16 minus 4 is 12. So in the numerator we will have x squared plus 12. In the denominator we have 2 times 4 is 8, 8 times x is 8x. So in conclusion, we found out that cosine 30 degrees equals to x squared plus 2f over 8x. And cosine 30 degrees is square root of 3 over 2, so we will get that square root of 3 over 2 equals to x squared plus 12 over 8x. We multiplied this equation by 8x, and we got the square root of 3 over 2 times 8x equals to x squared plus 12. 8 over 2 is 4, so we get that 4 times square root of 3x equals to x squared plus 12. And we subtracted square root of 4 times square root of 3x from this equation, and we got that x squared plus 12 minus 4 times square root of 3 times x equals to 0. And here we know that 12 is 2 times square root of 3 squared, so we substituted 12 by 2 times square root of 3 squared, and we got that x squared plus 2 times square root of 3 squared minus 2x, and we substituted 4 by 2 times 2, so we got here 2 times x times 2 times square root of 3 equals to 0. This expression is very similar to the algebraic identity that states that a squared plus b squared minus 2 times ab equals to a minus b squared, that equals to 0. In our specific expression, a equals to x and b equals to square root of 2 times 3. So a minus b squared will be equal to x minus 2 times square root of 3 squared, that equals to 0. We took a root of this equation, and we got that x minus 2 times square root of 3 square equals to 0, because the square root of 0 is 0. We added 2 times square root of 3 to this equation, and we found out that x equals to 2 times square root of 3 units. So we can write here that x equals to 2 times square root of 3 units. Here also x equals to 2 times square root of 3 units, and here also x equals to 2 times square root of 3 units, and here also x equals to 2 times square root of 3 units. Then we implemented, so now we can find out easily the area of quadrilateral ABCD. The area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle BDC. But because of the fact that triangle CDE congruent to triangle ADB, it is also true to find out the area of triangle ACDE, because it equals to the area of triangle ADB because of the fact that two triangles that congruent to each other, they have also the same areas. So we found out the area of triangle CD that is actually equal to the area of triangle ADB. So the area of triangle CDE equals to, here we do perpendicular from point D to S. So here in triangle EDS, sine 30 degrees equals to h over x, and x is 2 times square root of 3 units. In triangle ESD, sine 30 degrees equals to h over 2 times square root of 3. Sine 30 degrees is 1 over 2, and it equals to h over 2 times square root of 3. And here we multiplied this equation by 2 times square root of 3, and we got that h equals to 2 times square root of 3 over 2. 2 over 2 is 1, so we found out that the height of triangle CDE equals to square root of 3 units. The height equals to square root of 3 units, and therefore the area of triangle CDE, that is actually equal to the area of triangle ADB, equals to the base, that is CE, times the height, that is h over 2. The area of triangle CDE equals to the base, that is CE, times the height, that is h over 2. CE equals to 4. The height h equals to square root of 3 units, all divided by 2. 4 over 2 is 2, so we found out that the area of triangle CDE, that is actually also the area of triangle ADB, equals to 2 times square root of 3 square units. Okay, the area of triangle CDE, that is actually the area of triangle ADB, equals to 2 times square root of 3 units. Then we found out the area of this triangle, triangle CDE. We found out the area of triangle CDE according to a special formula. First of all, we calculated the semi-perimeter of triangle CDE. The semi-perimeter of triangle CDE equals to the perimeter of triangle CDE over 2. The perimeter of the triangle CDE is equal to the sum of its sides over 2, that is to say 2 plus 2 plus 2 times square root of 2, and when we divide it by 2, we will get the semi-perimeter. So the semi-perimeter equals to the perimeter of over 2, and the perimeter of triangle CD equals to 2 plus 2 plus 2 times square root of 3, and if we divide it by 2, we will get the semi-perimeter. So the semi-perimeter equals to 2 plus 2 is 4, plus 2 times square root of 3 over 2. 4 over 2 is 2, and 2 times square root of 3 over 2 is square root of 3. So we found out that the semi-perimeter of triangle CDE DBC equals to 2 plus square root of 3, and the area of triangle BDC is equal to the square root of S times S minus A times S minus B times S minus C. S equals to 2 plus square root of 3 units, A equals to 2, B equals to 2, and C equals to 2 times square root of 3 units. So S is 2 plus square root of 2. S minus A is 2 plus square root of 2 minus 2 is square root of 3. S minus B is 2 plus square root of 2 minus 2, that is square root of 3 also. And S minus C is 2 plus square root of 3 minus 2 times square root of 3, that is actually equals to 2 minus square root of 3. Here square root of 3 times square root of 3 is 3, and 2 plus square root of 3 times 2 minus square root of 3, it equals to, according to the algebraic identity, that A plus B times A minus B equals to A squared minus B squared. Here A is 2, so A squared is 2 squared, 2 squared is 4. B is square root of 3, and square root of 3 squared is 3. So 4 minus 3 is 1, 3 times 1 is 3. So in conclusion, we found out that the area of triangle BDC equals to square root of 3 units, and the area of quadrilateral ABCD equals to the area of triangle ADB plus the area of triangle DBC. The area of triangle ADB equals to 2 times square root of 3 units. The area of triangle DBC equals to 1 times square root of 3 units. And 2 times square root of 3 units plus 1 times square root of 3 units equals to 3 times square root of 3 units. So we found out that the area of quadrilateral ABCD, according to the second method, equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. So we found out in both methods that the area of quadrilateral ABCD equals to either 3 times square root of 3 square units, or in terms of numbers, it equals to 5.196 square units. Okay, thank you very much.